Guys, what's up? Econ John here. Welcome to our seventh part in our eight-part series on our advanced overview of monopoly, where we get into all the nitty-gritty details. In this video, we're going to talk about second-degree price discrimination. Let's go. So recall the basic setup as the following. We have two consumers with the following preferences. Consumer 2 is called our high-demand consumer, and consumer 1 is called our low-demand consumer. Mathematically, this means that the utility function for consumer 2 is going to be greater for every single x when compared to consumer 1, and the derivative is also going to be greater than consumer 1's for every value x. This over here is sometimes referred to as the single crossing property, these 2a and 2b. This implies that the indifference curves of these two consumers intersect at most once. This would be where one consumer is consuming 0 and another one is consuming some arbitrary amount. The constraint facing the monopolists are defined as the following, right? Again, where we have the utility for consumer 1 consuming quantity of good X, right? 1, meaning that he's consuming at his demand, minus R1, right, which is the bundle price for the bundle that's unique for consumer 1, must be greater than or equal to 0, and we have the same thing for consumer 2. Yeah. So pricing under second-degree price discrimination is nonlinear and would work if consumers are able to stay in their respective high demand and low demand positions. However, consumers who notice a deal that another one is going and getting may be tempted to switch markets. To make sure this doesn't happen, we impose a self-selection constraint, which is denoted by 4a and 4b. This just means that consumers are happier consuming their bundle than they are consuming another one, meaning that for consumer 1, he wants to go and consume his appropriate bundle, paying his appropriate bundle price than he would be if he was going and consuming consumer 2's bundle and paying consumer 2's price. So far, we've outlined the fact that there are two constraints in our problem. The first one is the monopolist constraints, which indicates that the monopolist must go and choose a R1 and R2 such that there is a non-negative consumer surplus. And the second one is a self-selection constraint, which is our consumers have to stay within their markets, right? So it follows that the bundle prices for our consumers must satisfy the following equations. So this is a little hard to deal with because mathematically, when we're faced with two constraints on each market, only one of these constraints will bind per market, meaning that for each R1 and R2, right, our determining factor for what that R1 will only be one of these equations. For R1, it will either be 5A or 5B. For R2, it will either be 6A or 6B. Let's first analyze our bundle price for our high demand consumer, and that price is R2. Let's say that 6A binds, right? That's our self-selection constraint. So this just means that we take this inequality and we just make it a strict equality. And we can say that 6B goes and becomes R2 is less than or equal to R2 minus U2 X1 plus R1. So this is our high demand consumer consuming the low demand good. And we end up going and having this result over here. So recalling our condition from 2a, where our consumer 2 must be having more utility from every good x, right? We have to go and say the following from the above result. So u1 x1 is going to be less than u2 x1, meaning that it's going to be greater than that, and that is going to be less than or equal to R1. So this over here contradicts a condition that we go and we have that for U1 X1 that has to be less than or equal to R1. So we just conclude by just a process of elimination by showing that this constraint over here, right, or really the second constraint, is contradictory to what we know about our other consumer. We have to go by default choose the other one, which is our self-selection constraint. So for our optimal bundle price for our low demand consumer, we know that that we have our self-selection constraint is for our high demand consumer is binding. So we know what R2 is. So let's go and assume that 5B is binding. So the process by which we're going and figuring these things out is that we're choosing a constraint and we're assuming that it's binding. This is because it's easy to deal with because we know that for our high demand consumer, we know what R2 is, and we can sub in an equation there. So just a little bit of algebra, we go and we get the following difference, right? Where U1 x2 minus U1 x1 is equal to U2 x2 minus U2 x1, right? So we have the difference between our consumers consuming these two bundles, one hot, bigger bundle and minus the smaller bundle. In calculus ease, right, you could just go write this as the integral evaluated of the derivative of each one of these functions, where it goes from x2 to x1, or x1 to x2, sorry. This, however, contradicts our 2b, right, which is our monopolist constraint, or no, sorry, that's not our monopolist constraint, but this is a condition of our utility functions, and thus we have to conclude that 5a is binding, or R1 is equal to U1 x1. So now that we've figured out what exactly R1 and R2 is, we can go and appropriately fill out the monopolist's profit function for solving this problem. So for a general function for monopolist using second degree price discrimination, we have this here, right? Where pi is equal to R1 minus CX1 plus R2 minus CX2, right? Where we're going and we're having a different bundle for each market, right? And we just go and sub in our equalities for R1 and R2, and we get this nice equation here where we can go and apply some calculus to go and solve for optimal X1 and X2 for each of these consumers. So in terms of visualizing second degree price discrimination, looking at figure 1, we see that our high demand consumer possesses surplus A, B, and C. So these are just the areas here. That's how we go and calculate his surplus for consuming quantity X of AH. While our low demand consumer only has surplus of A because we have two demand curves here, right? One is lower than the other, and that's because we have a case where our market is able to separate the market. In this case, there is no self-selection problem, meaning that there's no real incentive for our consumer to go and switch markets. In panels 2 and 3, figures 2 and 3, the changes in welfare when our monopolist goes and restricts output, right? As in he chooses to produce a single quantity and charge different prices in the markets. For our high demand consumer, we go and we see a change in the area, right, of AB minus EF, right? So that's just shown by this whole picture here. While the low demand consumers welfare changes is just A minus D, right? In this case, we have a self-selection problem because we have two different prices being charged here for the same sort of quantity. So that is our video on second degree price discrimination. In our next video, we're going to talk about third degree price discrimination and wrap up the series. I'll see you then.